Hey, these sure are an important type of question here. So important that we're going to do even more of them. Three more. I'm going to do the solutions all in this one video. These are all three calculator active problems. And let's go. Let's get cracking. If you want to see the actual scoring guides, they're real easy to find. You can just search 2003 AP Calculator Form B scoring guidelines, and it'll come right up for you. All right, so let's see for this one what we need to do. A tank contains 125 gallons of heating oil at time t equals 0. So right off the bat, we're being given an initial value, so that makes me think about like the fundamental theorem and like finding an antiderivative, and this is like that initial value. It's going to help me figure out like the plus c basically, so watch out for that. During the time interval from 0 to 12 hours, heating oil is pumped into the tank at this rate. During the same interval, heating oil is removed from the tank. So this is the classic, it's going in, it's going out kind of problem. How many gallons of heating oil are pumped into the tank during the time interval from 0 to 12? So if this is a rate, then the amount of stuff is the integral of that. And they only are asking not how many gallons are in the tank. They want to know how many gallons of oil are pumped into the tank. That is simply the integral 0 to 12 h of t. They named this function, so I don't have to do that. I don't have to write that whole thing down because I'm going to go ahead and put it in here. 2 plus, make a fraction. It looks just like this because I've got this fancy calculator, so I'm going to really use the full functionality of it, no pun intended. This one. Alright, and then I'm just going to take a sec to look and make sure that I've got that all right here. And then in y2, while I'm here, I'm just going to go ahead and put in this one, 12 is the sine. As soon as I ever hit that sine button or cosine or tangent, I'm going to go to my mode and make sure that I'm in radian mode because I'm in calculus class. So 12 sine of t squared over 47. And that looks good. Okay. So I want to do this. So I'm going to go back to my home screen, and I'm going to math 9 from 0 to 12. And I already have that in as y1, so I don't need to retype it now. I'm going to go to the variables menu, variables, and then I'm in function mode, so number 1 for function, number 1 for y1, and dx. So that's what I want to do. And that gives me 70.571, rounded correctly to 3 College Board decimal places. Make no mistake, folks. This is probably worth 2 points, 1 for this and 1 for the answer. If you don't have this, you ain't getting points. You have to write this, not just the answer. Don't like it? Too bad. Is the level of heating oil in the tank rising or falling at time 6? Give a reason for your answer. Well, whether it's rising or falling is going to depend on which one of these is bigger. If the pumping in is bigger than this, then it's rising. So I'm going to, and if it's being removed faster than it's being pumped in, then it's going to be falling. So I'm just going to find each one of these rates and then compare them. So to do that, I need to find, did you know that you can do this like function notation? I can bring up variables, y variables, number one, oops, that's not what I was trying to do. Variables, y variables, 1, and I want to plug in 6 into that. Did you know you could do that? Like y1 of 6. And then I also need to find y2 of 6. So I'm going to write these down. This isn't really probably part of the answer, like having these correct values, but I'm going to round them just to the 3 College Board decimal places, just because that's what we do. So now that I have those, the level is falling because R of 6, the rate that it's being pumped out, is greater than H of 6. I think that should do just perfectly. How many gallons of heating oil are in the tank at time 12? Well, let's see. At time 12, we've got this much is pumped in, and I know what that is. I already have that number there. This much is pumped out, and this much was in the tank when we started. I would call, forgetting this here, right, the plus 125, how much we had when we started, that's like the fundamental mistake of calculus there. It's a version of it. So I'm just going to put that all in there. So let's see, let's do math 9, just so that I end up rounding it properly. I don't remember what the next place was here, so I'm just going to do that again. I'm just going to put them both in the same integral here, from 0 to 12, and I'll put in here y1 minus y2, because it's the same limits of integration. y1 minus y2, y naught, and dx, and don't forget to add 125. Thinky. 122.026. And you know, just thinking about that, what we're doing here, I should probably put units on these. I don't think I need them there because I was just comparing, but these are gallons. They do attach, usually they put a units point on there when you're finding some kind of rate to make sure you understand how that works. So probably there's not a unit points here. I should have found the scoring guides for these so I could be sure that I was giving you the right answers. At what time for 0 to 12 is the volume of heating oil in the tank the least? And show the analysis that leads to your conclusion. So the amount of oil in the tank, let's call that A of T, is equal to the integral from 0 to time I don't know what, right? Whatever time you're interested in. H of, now I use the T here, so this is actually, I need to switch the variables here, right? That's that dummy variable. It can't be the same as this. Minus R x dx plus 1, sorry, I put too many dx's there. I should have just done that, plus 125. So that's how much there is in the tank. That's just exactly what we did in Part C. In Part C, we just did it for 12. So if you want to know when the volume of oil is the least, to find a maximum or a minimum, you take the derivative and set it equal to 0, and then check out to see if it is, in fact, a maximum or minimum. So the derivative of this is, if you take the derivative of this integral, back to t's now. Of course, derivative of 125 is 0. And we've seen this concept before, right? The maximums and minimums are going to happen when the two rates are equal to each other. Because if this one's bigger, then you're going to be increasing the amount. If this one's bigger, you're going to be decreasing the amount, and you're going to hit maximums and minimums when they're equal to each other. And we just showed that here. So let's see what happens if we set those two equal to each other. Let me just finish writing this work here. So I set that equal to 0. Probably there's a point for setting them equal to each other, or having this equation, which is the same thing. And then let's go ahead and graph. Now 0 to 1, 2. That's also known as 12, that number. These are the rates that it's going in and going out. They're always positive. So I'm going to go from 0 to, my rates like, that's a maybe 0 to 10 might be good. All right, that's the rate that it's going in. That's the rate that it's going out. So, so let's see. Let's think about this now. So here, going in is bigger than going out, right? So the amount is increasing up to here. So this is a maximum here. And then here, that's a minimum right there. Because there, the amount going out is greater than the amount going in. So let's find that intersection. So I can calculate intersect, and we got to move over here because there's two intersections. I need the cursor to be closer to this one. 1, 2, 3. So that happens at time equals 11.318. What's our time unit here? Hours. Okay. Show the analysis that leads to your conclusion. This is fine for an answer, and here we might want to say at time equals 11.318. This A prime goes from negative to positive. And we can see that here because of which one is which. You also could have just graphed this instead of graph the two of them and see where they're equal. Then you're looking at the 0, and then maybe that would be more convincing. So either way, we should be good there. Okay, that's number 2. That number 2. And number 3 here, I've got rate of fuel consumption versus time. Got a little table there, some of those values. Rate of fuel consumption in gallons per minute recording during an airplane flight is given by a twice differentiable. Why are they saying that? What does it mean? It just means that it's a smooth curve, so anything you want to assume about derivatives and the existence of them is legit, right? So we know that it's smooth here, and that the derivative of it would also be smooth, right? If it's twice differentiable, it means you could take the derivative of this and it would still not have any sharp corners. That is basically, they just need to say that so that we can assume all of the things that we think should be true are in fact true. So it's also strictly increasing. So even though we only know some of these points, we know that it's going up all the time. Function R of time t. Here's the graph. Table of selected values, time interval from 0 to 90. Okay, so use the data from the table to find an approximation for r prime of 45. So let's see, r prime of 45. 45 is right in between these, so a decent approximation would be to find the slope here between those points, and that should be approximately equal to that. So let's see. Slope is rise over run. So 55 minus 40. And what are the units of that? That's gallons per minute over run 50 minus 40. And that is minutes. So I'm putting the units in here because it's going to help me get the right answer, get the right units on my answer. 3 over 2, that reduces to, and that's gallons per minute per minute. You can write it gallons per minute over minutes, or you can do that. And there's a point for the units. The rate of fuel consumption is increasing fastest at time 45 minutes. Okay, so that's, in other words, this is the steepest. What is the value of r double prime 45? So that would be 0, right? R double prime of 45 is equal to 0 because, explain your reasoning, if r prime of 45 is a maximum and r is twice differentiable. I think probably you don't have to say that, but this is only true because they said that it wouldn't necessarily have to be equal to 0. It could be like a sharp corner. So if r prime is a maximum, that means that r double prime goes from positive to negative, which means that it has to be equal to 0 there. Approximate the value of this integral using a left Riemann sum with the 5 subintervals indicated here. Is this numerical approximation less than the value of this? So let's do our Riemann sum. Our Riemann sum, let's see, so I need the area of each one of these rectangles taking the height to be the left endpoint. So the first rectangle is 30 wide times 20 high, because I'm using the left endpoint for the height. And then the next one is 10 wide by 30. And then the next rectangle is 10 by 40. And then the next one is 20 by 55. And then the next one is 20 by 65. And let's see, what's this? 600 plus 300 plus 400 plus 20 times both of these. That's 120 if you add those together. 120 times 20 is 2,400, I think. So hopefully that's right. That's 1,000, so I got 3,700. And what would the units be for the area under this? Area of a rate gives us like the amount of stuff. So this is how many gallons were burned. You could think about it in terms of the area too. Area is multiplying, right? So when I do length times width of these things, I'm multiplying those together. Gallons per minute times minutes. Minutes cancel out, get gallons. Okay. is this less than that? Yes, this approximation is less than this. Now why? How do we know that? Well, if you do a Riemann sum of this, you could draw in the rectangles that we just did. Why are they all underneath? What is it about this function? Well, because this function is increasing. If this is increasing, then the left endpoints are always going to be the lowest value. So you don't have to say anything more, and because r of t is increasing on that interval from 0 to 90. All right. For times between 0 and 90, explain the meaning of this. Well, we just did the integral from 0 to 90, or at least we found an approximation for it. So what would it mean to do this? Well, from 0 to b, that's the amount of fuel used up to time equals b, right? And the units of measure for both answer, that would be in gallons, just like this was in gallons. And then what about if you do that value right here, the same thing times 1 over b. That's the average value of a function. So what's the average value of this function? The average value of this function is the average value of this thing, right? Not changing the units. It's the average gallons per minute. So it's the average rate of fuel consumption. I'm just going to use the exact same words that they have right there. It's the average rate of fuel consumption. And the units of that would be gallons. Now we're dividing by b, which is a time, so that's, of course, if it's the average rate of fuel consumption, it has to have the units of fuel consumption. So that would be in gallons per minute. Right? Same units as that, because we're finding the average value of that. All right, that one was a lot quicker than the other one. That only took about 8 minutes or something, maybe 9. All right, last one. For times between 0 and 31, the rate of change of the number of mosquitoes on tropical island at time t is modeled by this function. So this is the rate. So integral of this gives us amount of mosquitoes per day. And there's 1,000 mosquitoes at time 0. So at some point we're going to have to find some value and add that 1,000, right? Show that the number of mosquitoes is increasing at time 6. So the number of mosquitoes is increasing if this rate right here is positive. That's all. So R of 6 is equal to, let's go ahead and put that in here into y1. So let's see, 5 times the square root of t times the cosine of t over 5. I know those are x's, but I'm thinking of them as t's, right? And here, this is days 0 to 31. So, well, I'll go change that when I need to. Right now, all I need to do is find y1 of 6. Right? That's 4.438. Which is greater than 0. So the number of mosquitoes is increasing. It's probably enough just to say this, that that's positive. There you go. I like to be thorough, try to communicate with the other humans. Time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? So that's the derivative of this. So is the rate increasing or decreasing? So r prime of 6, and we can do this on the home screen, or you can graph it and do it there. I'm just going to do it on the home screen here. So math 8, that finds derivatives. So I want the derivative of y1 at x equals 6. It's negative 1.913, which is less than 0. So RT is decreasing at time 6. Right? What does that mean? Well, the number of mosquitoes is increasing, but the rate that it's increasing at is decreasing. So it's like increasing but concave down. If you were looking at a graph of like the actual number of mosquitoes, it would be increasing but concave down. So the number of mosquitoes is still going up, but the rate that it's going up at is decreasing. Okay? According to the model, how many mosquitoes will be on the island at time 31? And then round your answer to the nearest whole number of mosquitoes. Yeah, I guess I've seen parts of mosquitoes for sure, but we'll follow their directions. So the total number of mosquitoes is the integral from 0 to 31, the rate, because integral over rate gives you amount of stuff, but that's the change in the amount of stuff, and the amount of stuff, mosquitoes, started at 1,000. So let's do that. You could do that on the home screen too. I'm going to do math 9, go from 0 to 31, and y1. See, such a nice payoff if you learn how to do this. Put the y1 in there, I think, and don't forget to add 1,000. Come on, buddy. 964 mosquitoes. All right. Last part. To the nearest whole number, what is the maximum number of mosquitoes? So the number of mosquitoes, let's say, we could say amount. I don't like the amount there. Let's just call it number of mosquitoes at time t would be equal to, this is real similar to what we did in the first one in this video, I believe, 0 to time t, exactly what we did here. So if you want to find the max of the number of mosquitoes when n prime goes from positive to negative. So n prime, the maximum number of mosquitoes, take the derivative of this. Well, derivative of integral, that just goes away. So we'll set that equal to 0. Does that make sense to you intuitively that the maximum number of mosquitoes happens when the rate of change of the number of mosquitoes is 0? It should, because if you're going to max out the number of mosquitoes, then the rate, I mean the number of mosquitoes is going to be increasing, 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 and then at some point start decreasing, and that's where the maximum is. So that's where the rate has to pass through 0. So let's find that. I think we need to go to our graph. So I'm going to go to the window, make it 0 to 31, and I want to see where this is equal to 0. So I need to just make sure that I've got ymin and ymax that cross over 0. It doesn't really matter what you make these, because I'm just interested in where it crosses. But I know that the rate, those are like the, I don't know if that's a typical number, so I guess you could just do like the minus 10 to 10, why not? But it doesn't matter, because all we need to do is see where it crosses. Okay, now it crosses in 2 places, so let's be clear. Here it's going from positive to negative. That's what we're looking for that maximum. Here it's going negative to positive, so this is the minimum number of mosquitoes here. So here, let's find that 0. It looks like it's between, it's in the first half anyway, so it's between 0 and 15 if you don't want to use the cursor. So let's go 0 to 15, and we'll be able to see it show up there. Yep, we found the right spot. At time 7.854. This is days, right? Yeah. That is when it happens. So what is the actual maximum number of mosquitoes? It's this. And let's go back to the home screen. So I can just bring this up again. I'm going to go second entry and just click back through here and change this to 7.854, and that gives me, better be bigger than 1,000, right? If it's the maximum number of mosquitoes. So it looks like 1,039 mosquitoes. There you have it. I'm going to look up the scoring guides and check my answers, make sure I didn't mess up.